Okay, our answer is
3,000. 6,000.
3,000.
3,000.
No, no, it's 3,000.
okay. The answer is 3,000.
School recreation.
The answer is 3,000 and it is in joules. We have said that for work to be done against gravity means that body is moving horizontally. Sorry, vertically. Vertically means we are moving from the ground going upwards. So they have given it to us as a height of a staircase in this question. So for us to get that work done, remember in definition, we are dealing with a force. Now, for this work done against gravity, we are going to be using weight of that body that is moving. So weight, I've told you that is determined from mass of a body multiplied by the acceleration due to gravity. And acceleration due to gravity is a constant. It is given to us always as 10 meters per second squared. So whenever they give you a mass, which is in kilograms, to make it a force or to make it a weight, you multiply by 10 meters per second squared. So it becomes a weight. That's what we have done here in our solution. So you realize that we have 60 times 10, which is now the weight, then times 5, which is the distance in meters. So the answer that we have got for that is 300 joules. So that is our first example for work done against gravity. Okay, let us go straight to example 2. There is the example. And I request you to try it and we see which answer we get. We have 3 minutes for that. Now this work, please, is in joules. You help me correct that. This one here, it's not newtons, it's joules. Because work is in joules. So in this example, they have given us the weight of a box, and they have also given us the work that is done to move that box upward. And they are asking us for the height of an inclined plane. An inclined plane is something that looks like this. Where this one here is the ground, then it has a certain height, and we have to move a body from this point, moving upwards. Now the height of the inclined plane is this one here, and we can call it h. So if weight of this body is 550 newtons, and they have given us the work done as 1,375. So we'll be having our formula that work done our work is going to be we're going to have work being equal to, remember it's done against gravity, so it will be weight of that body times the distance that is traveled, or the height. Now, according to what we have in our question, they have given us the work done as 1,375. So it's going to be equal to the weight, which is 550, times the distance, which we don't know. But from this diagram that we have drawn here, we have said, let us keep it as h. So what we do after here, now there are some people trying to disorganize us, please. Okay, so what we do after here is to divide through by 550 on both sides, by 550. So when these ones cancel, and which height do we get? Those ones with calculators can help us. All right. Now we will be having our answer as 2.5. And because our work was in joules and we had our weight in newtons, the h, which is the height, will be in meters. So our answer is going to be equal to 2.5 meters. So that is it for that is it for that. Let us go to something else. Now we are going to be looking at another part because now work is done. We have understood what work is. For our friends who have just joined us, we are looking at work, power and energy. And for this lesson specifically, we have reviewed a work that we had in the last lesson. And we have also looked at work against gravity that we have just finished. So if you have just come, you just concentrate and join us on our next slides, such that at least you can understand the power part. Then this work part, you will be reviewing the recordings and you will be asking any questions thereafter. Now I want some of you to let us know, someone speaks about power. What comes into your mind? Someone speaks about power. If I talk about power, what comes into your mind? Have some hands up here. Yes, May.
Good afternoon, teacher.
Good afternoon.
Whenever I hear the word power, I think of machines. Yes.
Okay, May thinks of machines. It's Matthew.
When I think of power, I think of ability to do work.
Matthew thinks about ability to do work. Yes, Nancy.
I think power is the rate of doing work.
So rate of doing work. It's power. Yes, Realm.
I think power is the force produced while doing work.
Was produced while doing work. Okay, yes, Victor. Victor.
Power is effort applied to do work. That's what I think.
Okay, effort applied to do work. Yes, Harriet.
I think power is the effort applied in order to perform a job or a task.
Effort applied in order to perform a job or a task. Okay. Yes. Yes, Daniela, your hand is up.
I think power is the rate of doing work.
Yes. So Daniela thinks power is a rate of doing work. Lastly, Israel.
I think power is the rate at which work is done.
The rate at which work is done. So all of us have an idea on what power is. So here they are telling us that if we have two people, P and Q, so person P and then person Q, and these people carry a load of 50 newtons through a distance of 10 meters. We say both of them have done the same work. Why? Because they have the same force and they have moved the same distance. But if P did work in 20 seconds, whereas Q did work in 40 seconds, there is one who is more powerful than the other. The more powerful person will do work easily or in less time, whereas the less powerful person will do work, but will take a lot of time. So therefore, if someone speaks about power, that person is speaking about work done, but with an element of time. Therefore, our definition for power will be the rate of doing work. How much time do you take, or how much work do you do in a certain time. That is what we call power. So power is defined as the rate of doing work. Let us put that in our notes as we note down. And the SI units, or the units for power, are watts, or you can also have units of joules per second. Because if someone speaks about rate, then he's speaking about getting work divided by time. And we are going to see it here in our formula. So this is the formula for power. Power is work done divided by the time that is taken. So you'll have power as work done then divided by the time that is taken. It means that because work is force times distance, I can get my power as force times the distance divided by the time taken for us to move that distance. So that is the formula that we use for us to find power. Now, after us noting what power is, I think we can look at some few examples and see how we can use this calculation. So example 1 says, we calculate the power developed when a force of 50 newtons we are determining the power developed when a force of 50 newtons is acting through a distance of 3 meters in 2 seconds. So we have 2 seconds as our time. We have 50 newtons as our force, and then the 3 meters as our distance. So how will we get our power using that? How will we be getting our power? So from the formulas, we have realized that for us to get power in watts, we have to get it from the force multiplied by the distance, then divided by the time. The force has to be in newtons, the distance has to be in meters, and the time has to be in seconds. So it means we'll be having 50 as the force. We'll be having 3 as our distance in meters. Then we'll be dividing by the time, which they gave us as 2 seconds. So this one will give us 150 as the work done, then the time is 2, and our answer will be 75, and these ones are watts. So that will be our answer for our first example, 75 watts. All right, after getting that, let us look at the second example. The second example is this. Tom uses power of 600 watts to climb up a staircase of 6 meters in 5 seconds. So they want us to get the weight of Tom, but they have asked us in this way. What would be the reading in newtons on a weighing scale if Tom stepped on it? So they want us to get the weight of this person. And we said weight is the same as force because weight is a force. So they have given us the power, we have the distance, we have the time. The only thing that we don't have is the force. So they want us to calculate the force in newtons. What do we do here? We get our formula that for us to get the power, for us to get power, we are going to use power is equal to work done divided by the time that is taken. According to what we have, our work, we already said it's calculated from force, time was the distance, and then we divide by time if we are to get power. So divided by time. Now, according to the question, they have given us our power as 600, and they have given us the force. Oh, we are looking for the force, sorry. But they have given us the distance as 6 meters, and the time that they have given us is 5 seconds. So if we are to continue working this out, we have our 600, which is now our power. 600 watts is equal to F times 6 gives us 6F, and we are dividing by 5. Now on this stage, what we are going to do, we are going to multiply by 5 on both sides. So we'll be having these 5s here canceling out. 5 times 600 gives us 3,000. And 3,000 is equal to 6F. So if we divide by 6 on both sides, we'll be getting our F, which is the weight or the reading in newtons, as the 500, and this 500 is going to be in newtons. So that is our answer for that example 2 that we are looking at. Okay. After we have got that, let us try out these few questions. We are going to start with question 1, 2, and 3. So in our books, we write these questions and we try answering them one by one. Okay, we are having answers. Many of us have up to number 3. And I hope each one of us has tried so the answers for number 1 is 58.8 watts. Those are the answers that we have. Number 1, the answer is 58.8 watts. Number 2, the answer is 6. Now, number 2, the answer is 1500. This is in watts. Now you realize number 2, they gave us this as mass in kilograms. And I told you that if you're going to calculate anything which involves force times distance, then it will have to change. We will multiply this mass times 10, which is the acceleration due to gravity. So we'll get the force as 6,000. If you multiply it by 100 meters and after we divide it by 40 seconds, our answer for number 2 will be 15 with 3 zeros. So it is 15,000. Then for number 3, many of us have gone for crane A. Crane A has a force of 400 times 10, which is 4,000. The distance is 10 meters. And the time is 4, which gives us 1,000. Then crane B has the 3,000 as the force, multiplied by 15. And when we divide by 5 seconds, then we get 9. This is 4,000. This one we get 9,000, whereas for the first one we get 10,000. So you realize that the 10,000 is more than the 9,000. So crane A gives us more power. So those are the 3 answers. If you didn't get any of them, you please correct. So let us continue with the exercise. We now look at number 4 and number 5. Number 5, we are only doing part A. Paula is asking if the weight is in kilograms. Now, weight cannot be in kilograms. What is in kilograms is mass. So what you have to do when your mass is in kilograms, you just multiply it by 10. You don't need to change it to grams. However, if they give you mass in grams, then you have to change them to kilograms, and after you multiply by 10. Hope you have got that, Paula. Now, the reason why we have 15,000 on number 2 is that they gave us mass as 600 kilograms. I told you if they give you mass, then you make it a force by multiplying by 10, which is acceleration due to gravity. So that means our weight will be 6,000. Now that 6,000, remember we have to multiply it by the distance, which is 100, and then divide it by 40. So it means that we are going to be having the 6,000 times the 100 divided by 40. So you'll be having 1 0 going off. And when you divide by 4, you will be getting 1 and 5, then the 3 zeros. That's why we are getting 15,000. So you please correct that. Now for number 4, you realize that they have not given us a time, but you see that they have given us something that they have called velocity, which is in meters per second. So if they say meters per second, it means that the 14 that they have given us is a distance divided by a time, because we have meters per second. The meters are for distance and the second is for time. So that means that from our formula of power is equal to force times distance out of time, these people have put the time together with the distance. So that ratio of distance and time is what they have given us as velocity, which is 14. So we are just going to use the 500 and we multiply it by the distance over time, which they have given us as the 14. So the answer you get by multiplying that force times 14 is our answer. So hope I've sorted that thing of no time. The time from our formula, we have force times distance divided by time. But they have given us that ratio of distance over time as 14. So in other words, we are multiplying the F, which is the force, times that 14, and we have got our answer as, some people have 700 watts. Hope it's correct. 700 watts. Okay, after doing number 4, Then we do number 5, part A only. Let us do number 5, part A. Our number 5, part A will give us 50 watts. Now the time that we have to use has to be time in seconds. So as you are calculating, make sure you put that time in seconds. If you don't change it to seconds, then you're getting something which is not correct. Time has to be in seconds. As someone has said, he has not understood how we did number 5. Number 5, they gave us the work as the 180,000 joules, and they gave us the time as 1 hour. They are asking for the power. And we say that power is work done out of time taken. Now the work has been given to us as 180,000 and the time as 1 hour. So you have to change the time to seconds by realizing that 1 hour has 60 minutes, and each minute has 60 seconds. So that means the time is going to be 60 minutes times 60 seconds, which will give us 3,600 seconds. So our power that they are requesting for is going to be got from 180,000 divided by 3,600. And then we will be getting our answer as 50 watts. Want us to do more examples? Okay, I want us to continue doing some more examples so that we can get familiar with this. There is the assessment exercise. If you look at question 1, assessment exercise, question 1. They're asking us that a machine lifts loads of 2,500 newtons to a vertical height. So they're asking us for power developed, and then they're also asking you for the time for something. So let us try it out. Let us try to do number 1. Number 1, Roman 1 and Roman 2. Number 1, Roman 1 and 2, we are calculating power. So we are having 5, some people have 5,000, others have 500. So I don't know which one is correct. We are going to try it together and see. Now they have given us our force as 2,500. So if we get that 2,500, multiply by the distance is this vertical height, which is 3 meters. And then we divide it by the time, which is 1.5. So you realize that you will have your answer as 5,000. And that 5,000 is in watts, because they are asking us for power. Then they have told us that if we use the same power, how long will it take for us to lift 600 newtons through a vertical height of 5 meters? Now we have the same power, and our power is the 5,000. And they are telling us that now the force has become 6,000. The distance is 5 meters, but we don't know the time. Now for this, we'll be having our 5,000. It will be equal to 6,000 times 5. It will give us 30,000. Then this T, which is here, if we multiply it on both sides, like that, you realize that this way it will cancel out, and here remain with 5,000 T. So we divide through by 5,000, and we divide this side also by 5,000. You realize that the time you'll be getting will be equal to 6 seconds. Now, if you don't have energy to write seconds in full, then write a small s. Don't write sec. Sec is not a unit for seconds. You write a small s, or you write the full amount. So those are our answers for number 1. So let us try out number 4, 5, 6, 7, and 8. We can first copy them down. Number 4, 5, 6, 7, and 8. Number 4, 5, 6, 7, and 8. Now, someone was asking me about number 2. Number 2 is part of energy, and that will be in our next lesson. So let us do these ones that we are done studying. We are doing numbers 4, 5, 6, 7, and 8. Have we copied all the questions? Number 4, 5, 6, and 7. Okay, if you are done with the questions, let us see, try them out in our books. I will send your answers in the group such that I can mark them. So you will have to send that work in our WhatsApp group so that I can mark your work. Otherwise, you allow me stop here for today, and we'll meet again in our next lesson next Friday. Thank you for staying around, and I hope you have a nice weekend. So see you again next time.